Again, they have this long explanation of all the transformations. What we're going to do is we're going to move that k over to the other side. I'm going to keep the same letters here. We're going to move that k over to the other side, and we're going to do transformations the same way that we did transformations back when we did Chapter 3, which is instead of having to worry about all of this information, we're just going to move from left to right like we did before. So once we move that k over to the other side, we're going to move from left to right. And on this page, you've got some space on page 346, we're going to add an example. We're going to add the following example. We're going to graph y equals negative 5 times 3 to the 2x plus 4 minus 7. Now, what makes graphing exponentials a little bit harder than graphing a square root function or an x cubed function is it's a little bit harder to recognize them. Not that much harder. I mean, where's the x? The x is in the exponent. As soon as you see that, you know it's an exponential function. But what makes it a little bit harder is that the parent graphs of an exponential function have a number in them. So when we're looking at this one, we have to figure out what is our parent graph for this one. What is the base graph that you would have before you do your transformations? Well, it's an exponential function, so it's going to be something to the power x. What's the base of this one? 3. That's what makes it a little bit harder, is because there's a number right here that's part of your parent graph. And sometimes you're going to be tempted to use that number in your transformations. So you have to think, that is part of my parent graph. That's not affecting my transformations. As I go from left to right, the first number I run into is a minus 5. What's that minus 5 going to do? It's going to stretch it vertically. It's going to multiply our y values by minus 5. Then the next number we run into is not the 3, because the 3 is part of our graph, but the 2. And the 2, if we think of all of this inside the red box here, is all of the stuff where the exponent is, or where the x value is. So everything in that red box is going to affect things horizontally. So what does that 2 do? That's going to multiply our x values by 1/2. Good. What's the 4 going to do? It's going to move it 4 to the left. And notice this one's already in the factored form. So we're going to get somewhere we have to remember whenever you have a horizontal stretch compression with a horizontal translation. Remember, we always had to factor that out. This one's already factored. Then finally, the minus 7, that's going to move it 7 down. So in order to figure out how to graph this, the first thing we're going to do is we're going to draw a quick sketch off to the side of our parent graph. Label the key points 0, 1. In this case, it'll be 1, 3. We have our asymptote at y equals 0. And then to draw our new graph, we're going to take those 2 key points and our asymptote and apply our transformations. So we're going to say, what happens to 0, 1? What happens to 1, 3? What happens to our asymptote y equals 0? And moving from left to right, little reminder, we did this was already like 2 months ago, a month and a half. The first thing moving from left to right is all of your stretches and compressions. So the minus 5 will multiply your y by negative 5. And we can do the horizontal stretch compression at the same time. The 2 will multiply our x by 1/2. If we do that to 0, 1, we will get 0, -5. If we do that to 1, 3, we will get 1/2 -15. After doing our stretches and compressions, and I'll do the asymptote at the end, we can do our translations. So moving from left to right, the next number is our 4. We already said that goes left 4, and then we're going to go down 7. So we'll have -4, -12, and -3.5, -22. Now I left the asymptote for the end because one thing we're going to find out is that when our asymptote is at 0, your stretches and compressions won't affect it because you're multiplying 0 by something. The only thing that's going to affect your asymptote that's at y = 0 is whether it gets moved up or down. And we move down 7, so our asymptote will be at y = -7. So when graphing exponential functions, just to recap what we've done so far, we have to recognize what's the parent graph first, draw a quick sketch of it with key points 0, 1, and in this case it's 1, 3. We apply our transformations to those 2 points. We also apply the transformation to the asymptote, but the only thing that's going to affect an asymptote at y = 0 is whether you move it up or down. So in this case, we moved down 7, so our asymptote got moved down 7. And now that we've got all of this information, we can create our graph. The first thing we'd put on our graph is our asymptote. So I've got y = -7 here. Plug in our points. So we've got -4, -12, and we've got -3.5, -22. I'll estimate that that's down there. If I'm going to go through those 2 points and still approach my asymptote, it has to look this way. So it still has the shape of an exponential, although some stretches, compressions, reflections have happened to it. And once you've got those 2 points, you'll know which way the asymptote, which way the graph has to go, because it had to go through -4 and -3.5 going down. So it meant it had to approach the asymptote going up to the left. Some other things you can do with your graph once you're done is you can just sort of imagine what would have to happen to this graph if I multiplied by a -5. That -5 affects your y values. That would have it flip down and stretch. Then you're going to also compress it by a half, so that'll maybe make it even steeper than it was before. Finally, it's going to get moved 4 to the left and down 7. So our final graph, well, those are beautiful arrowheads, should look something like this, which seems to match up with what we've graphed.